Sometimes the simplest questions hide the most incredible complexity. Today, we're going to explore one of those. It's a puzzle that, on the surface, seems so easy, but it's so vast it touches everything from planning a holiday to how our own DNA is put together.
So, to really get a feel for this, let's start with something we can all understand. No jargon, no complicated math, just a simple trip. I mean, have you ever tried to plan the perfect road trip? You've got your list of places you absolutely have to see. You know where you're starting, and you want to visit every single spot. But you want to do it in the smartest way possible, right? Without wasting any time or gas.
Okay, let's picture it this way. Imagine each of your destinations is a dot, a city on a map. The challenge is simple, really. Start at your home city, visit every other city just one time, and then head back home. The big question is, what's the absolute shortest way to do it? And when you're just looking at a few cities, our brains are pretty good at this. You can almost just see the best route, can't you? It feels obvious. But what happens when we add just a couple more stops to our trip? This is where our simple little road trip suddenly becomes one of the hardest puzzles in all of computer science. This is where things get interesting. So with just 4 cities, figuring out the shortest path is, it's not a big deal. You can kind of just map out the few possibilities in your head. In fact, if you do the math, there are only 3 unique round trips to even check. That's it. A computer could figure that out instantly. All right, but let's make it a little more ambitious. What if we have 10 cities on our list? Still a pretty reasonable tripe, right? So how many possible routes do you think there are now? A couple dozen? Maybe? 100? Nope. The answer is over 181,000. All of a sudden, our simple little problem has turned into a really serious task. Just trying to check every single one of those paths would take a long, long time. Okay, let's push it one more time. Let's double it again, from 10 cities to 20. Now we're talking about a real delivery route, or maybe a very, very ambitious vacation. The number of paths, well, it doesn't just grow, it explodes. For just 20 cities, the number of possible routes is over 60 quadrillion. I mean, that's a number so big it's hard to even imagine. To put it in perspective, if you had a supercomputer that could check 1 billion routes every single second, it would still need almost 2,000 years to check them all. This incredible growth is what makes this puzzle so tricky. So this problem, which starts out so innocently, actually has a name. It's a famous challenge that has fascinated and, let's be honest, frustrated some of the smartest people in the world for decades. And what they call it is the Traveling Salesperson Problem. It's the ultimate challenge of trying to find that one, single, perfect, shortest route out of a nearly infinite number of possibilities. And this isn't just some abstract puzzle. Think about it. A trucking company needs the most efficient delivery route to save fuel. A robot in a factory needs the fastest path to drill hundreds of holes on a circuit board. Scientists even use these ideas to help piece together strands of DNA. So solving this, well, it could save an incredible amount of time, energy, and money in the real world. The reason it's so famous for being difficult is because it belongs to this special class of problems called NP-complete. Now, that's a pretty technical term, but the main idea is actually simple. It means that as you add more cities, the time it takes to find the absolute perfect answer just blows up. To this day, nobody has found a clever shortcut to solve it perfectly every time. If you did, wow, you wouldn't just be famous, you would literally change the world. So, if finding the perfect answer is pretty much impossible for any real-world problem, what do? Do we just give up? Well, no, of course not. We change the goal. And this is where we start to think a little differently. Instead of that impossible search for the one perfect path, we start looking for clever shortcuts. They're called heuristics. And really, a heuristic is just a rule of thumb, a practical method that isn't guaranteed to be perfect, but it's usually good enough for what we need. And these clever shortcuts are what make things like package delivery and modern logistics even possible. We basically agree to accept a little bit of imperfection in exchange for getting a really, really good answer now, instead of waiting 2,000 years for a perfect one. Here's a really simple example of one of these shortcuts. It's called the nearest neighbor approach, and it's super intuitive. All you do is start at your home city. Then you just go to whatever unvisited city is closest to you. From there, you look around and go to the new closest city. You just keep doing that over and over until you've hit every spot, and then you head home. Now, will that simple rule always give you the absolute 100% shortest path? No, probably not. But what's amazing is that it almost always gives you a path that's really, really close to the best one. And it finds it in seconds, not millennia. It's this beautiful trade-off, isn't it, between perfection and just getting things done. And that idea of trading perfection for a good enough solution, that brings us to a final thought. Because it's not just something computers do. It's a deeply, deeply human thing. Just think about it for a second. From figuring out your schedule for the day to making a really big life decision, we almost never have enough time or information to find the one single perfect path forward. So instead, we use our own shortcuts, our own intuition to find a route that works, a solution that's good enough. And you know what? Most of the time, that's more than enough to get us exactly where we need to go.